what is the value of a, given that you have 5 to the power of a plus 5 to the power of a equals 100. Then let's have it to be solution. From here, we have 5 to the power of a in common, so let's factor it out to be 5 to the power of a. Then we have to open the parentheses. This 5 to the power of a divided by this will be 1, plus this 5 to the power of a divided by this will also be 1, equals 100. So from here, let's add this together. It will be 5 to the power of a multiplied by 1 plus 1 will give us 2, equals 100. So from here, let's divide through by 2. So this and this will cancel. So we are going to have 5 to the power of a equals 100 divided by 2 will give us 50. Then let us recall that to get the possible value of a, we have to introduce log to both sides. So from here we have log 5 to the power of a equals log 50. Then when we have log p to the power of m, the power m will come down to base to be m multiplied by log p. So from here, we are going to have a multiplied by log 5 equals log 50. So let's divide through by log 5. We are going to have this to be divided by log 5, this to be divided by log 5. And so therefore, this we cancel out this. We are going to have a to be equals log 50 divided by log 5. Once we can have 50 to be the product of 5 times 10. Let's put them in parentheses. So when we substitute this one here, we are going to have a to be equals log 5 times 50, then divided by log 5. Then once again, when we have log a times b in parentheses, this can be simplified as log a plus log b. So when we apply it here, we are going to have a to be log 5 plus log 10 divided by log 5. And let us recall that when we have a plus b divided by c such that a, b, and c are constants, we can have this as a divided by c plus b divided by c. Let's apply it here. We are going to have a to be log 5 divided by this log 5 plus log 10 divided by this log 5. So we divide through by log 5 this and this. And so from here, a will be equals 5 divided by 5 will be 1 plus log 10 divided by log 5. Then let us note that we can have 10 to be equals 5 times 2. So from here too, we have a to be 1 plus log 5 times 2 divided by log 5. So from here, we have a to be equals 1 plus log 5 times 2 divided by log 5. A will be equals 1 plus log 5 plus log 2 divided by log 5. Then a will be equals 1 plus log 5 divided by log 5 plus log 2 divided by log 5. A will be equals 1. when this divided by this will be 1 plus log 2 divided by log 5. 1 plus 1 will give us 2 plus log 2 divided by log 5. Then let us note that when we have log a divided by log b, this equals as when we have log a in base b. So applying it here, we are going to have a to be 2 plus log 2 in base 5 to be the value of a. So now let's just check. So to check, we have to recall that we have 5 to the power of a plus 5 to the power of a equals 100. When a equals this, then let's substitute it here. We are going to have 5 to the power of 2 plus log 2 in base 5, again plus 5 to the power of a equals this, 2 plus log 2 in base 5, then it's going to give us 100. So from here, we have this to be repeated 2 times, meaning we can factor it out to be 5 to the power of 2 plus log 2 in base 5. When we open parentheses, the first time here, divided by this, they are the same, it will be 1 plus this. This first time here divided by this, it will be 1. Then the question now is it going to give us 100? So we have 5 to the power of 2 plus log 2 in base 5. 1 plus 1 will give us 2. Then it's going to give us 100. So from here, we have to note that when we have a to the power of m plus n, from the law of indices, we can simplify this as a to the power of m multiplied by a to the power of n. So applying it here, we have m to be 2, n to be log 2 in base 5. And our a will be 5. So here will be 5 to the power of 2 as we have it here, multiplied by 5 to the power of log 2 in base 5 as we have it here. Then multiply by this constant 2. Then it's going to give us 100. 5 to the power of 2, this simply means 5 times 5, which will give us 25, multiplied by 2, multiplied by 5 to the power of log 2 in base 5, then it's going to give us 100. So 5 times 5 is 25 plus 5 multiplied by 5 is 50, multiplied by 5 to the power of log 2 in base 5, then it's going to give us 100. So from here, we come when we have a to the power of log b in base a. So far they have the same base as this. The output of this will be b. And this implies when we have 3 to the power of log 4 in base 3, this will be equals 4. This and this are the same, the output will be this. So here will be 50 multiplied by this and this and the same, we have here to be 2. Then it's going to give us 100. 2 times 0 is 0. 2 times 5 will be gives 10, make it to be 100, equals 100. So therefore, a equals 2 plus log 2 in base 5 is correct. So mind you, we can also have it as shortcuts. When we have 5 to the power of a plus 5 to the power of a equals 100. So far this is repeated 2 times. We can have it as 5 to the power of a multiplied by 2 equals 100. Dividing through by 2, this and this will cancel. Here will be 2, here is 1, 2 here will be 50. So from here we have 5 to the power of a equals 50. When we introduce log, here will be log 5 to the power of a equals log 50. And so from here, this implies we have a to be equals log 50 divided by log 5 from here. So we have this to be expressed as log 50 over log of 50 in base 5, and this also equals as when we have 2 plus log 2 in base 5. They are the same, but this is the easiest way